Hello, everybody. Good morning. That's a pleasure for me to open this session of the second day, and that's a lot of pressure on me. So I'm Yann Bocchi, and today I would like to highlight some specific projects and use of IoT technologies in different projects. And I choose the two projects to talk about, and it's different applications of smart cities services in mountain area, in remote area. So first of all, I will just briefly introduce myself. So I work at the University of Applied Sciences of Western Switzerland. So we are a university basically interested in developing innovations and application on the field. So we are not doing fundamental research, but really application. We are looking for applications and innovations. So my background is more on tech side. So I come from telecom engineers formations, teaching, and I work on smart city projects since 15 years. So my point is, when we talk about smart cities, usually it's concern half of the population, because it's well known that half of the populations is living in urban area. But in the meantime, that means that the other half of the population doesn't live in urban area. So we need to find some way to address and to provide them smart city-like services, even for these people, in order to do not dig a gap between people living in urban area and in remote area. So the two projects I will present you later on are done in collaboration with the Mobility Lab. What is the Mobility Lab? This is an initiative in Switzerland between the Swiss Post, the Swiss Federal Institute of Technology in Lausanne, EPFL, my university, HES-SO Valais, the local government of the canton of Valais, and the city of Xian. You have to keep in mind that the city of Xian is the biggest city in the area where I live, but it's still less than 40,000 people, inhabitants. So in some way, it's more a big village rather than a small city. And the point is, okay, when you live in this kind of area, how could you propose smart city-like services in, I would say, an efficient way and a clever way, I could say. This is an example of a road who is not so far from my office, who reached a ski resort with a lot of people during winter time. Foreign people, local people go to this very famous destination with a lot of activities during that time. Does it make sense to deploy fixed sensors in this road if you want, for example, to know what is the status of the road, if there is snow, or if it's wet, if it's dry? For sure, it does not make sense to deploy this fixed sensor. So, for this first illustration, for the first use case, we addressed this very specific problem we have in our area, in mountain area, about snowing. So when you have a lot of snow, roads could be congested, you have a lot of traffic, you have tourists that do not have the proper equipment on their car, like snow chains or winter wheels or something like that. And we would like to provide some information systems for local people and both foreign people and tourists to know what is the status of the road, to avoid this kind of situation when you have people just in the middle of the road putting the snow chain and starting to make traffic congestion on this road. You could say, okay, you can just have a look to the weather forecast or to the meteorological information systems, but it's not enough, because in mountain area, you have some people who are working in road maintenance, and they are doing well their job. So sometimes you could have this kind of situation when the weather forecasts say, okay, it snowed maybe 2 meters of snow, but the road's still dry because the snow clearing machine passed and the road maintenance guys did their job very well. So it's not enough to base only on weather information. That's the reason why, coming back to this picture, rather than to deploy thousands or hundreds of fixed sensors to know what is the status of the road, we decided to deploy only dozens of them on a mobile element. Which is a mobile element? Maybe you can see it on the in this picture. This is a bus operated from Swiss Post. And you have to know that Swiss Post is the main public transportation operator in Switzerland regarding bus operation. And since a couple of years, all buses of this fleet are equipped with 3G and Wi-Fi connectivity, initially to propose Wi-Fi internet access to the passenger. And the idea of the first project is to put a specific sensor on the bus, and the bus is just moving around on the road, collecting data, and using this 3G connectivity to push this data to our systems. And this is the NOSE project, named, the acronym mean Nomadic and Modular Sensing Ecosystem. So you can see this sensor. We didn't develop this sensor. We just brought it to an industrial partner, and we put it on some buses as an experiment. And the buses are collecting data along their way and pushing their data in our system. And at the end of the day, we were able to provide some services both for bus drivers, for tourists, and for local people using this road through an application that we developed. You can see a kind of print screen. So there is a main road. So this is the final destination with this very, very famous smart ski resorts I mentioned earlier. And you have just this different color that could indicate where the road is clean, if it starts to be messy, or if it's totally snowed. And based on this, on that, drivers can take the decision to say, okay, I better to stop maybe a little better earlier to put my snow chains and avoiding to be in a tricky situation later on. The second project I would like to share with you is based on a very, I would say, new network concept named floating content. So you have to imagine some pieces of information literally floating in the air around a specific area. Okay, that's the main way to represent yourself what could be floating content. So. Basically, it's relied on a specific network infrastructure that's in fact not an infrastructure. So you don't need any cellular-based infrastructure or Wi-Fi access point to use this kind of network. All devices in a specific area can share directly information in between without going through cellular antennas or Wi-Fi access points. So that's called that could be called peer-to-peer networks or ad hoc communication or opportunistic communication. And as I said early, we want to find application of this kind of new network concept. And the first one was to develop an application for post-disaster communication. Imagine, so we live in a mountain area. We have a lot of earthquake. Sometimes they are small, but sometimes they are bigger. And in preparation, maybe of the big one, as they call them in California, we could prepare themselves. We could prepare ourselves and the population by downloading this specific application. That's able you to still continue to communicate even without infrastructure. And this application is based on a very, very basic message exchange. You have 4 kinds of message. You can declare a victim, a resource, an healthcare point, or a danger source. And you can just see what is around your specific area. So because in that situation, you can imagine that you don't want to know what happens 10 kilometers from your position, but you're really interested in knowing what's happened maybe in half a kilometer around you. So that's the purpose of this application. You can download it on the Google App Store. It's named Floater. And this kind of floating content application can be also applied in autonomous vehicles. So we are running in the frame of the Mobility Lab a nice experiment since almost 4 years in the city of Xian, operating smart shuttles like this. So these are small autonomous shuttle. And you can imagine when in the future, when you will have a lot of autonomous vehicles on the road, they need to share information, but just in proximity, when they want to manage themselves to give priority when they come to a crossroad. You don't need to push this information in a central item or server or something like that. You have to make these two vehicles communicating directly between themselves, even to maybe to warn from a specific accident or something like that. So these are the kind of application we can do with this floating content. And last, and I will come to AI, and by extension machine learning, we are still working on using this floating content concept to apply it on federated learning. Federated learning, in 2 words, is the ability of a group of, I would say, disparate devices to build a big picture without any central view. So any of this device can just collect the information they are seeing just around them and share with the next device close to them. And during this exchange of information, each of the devices are able to build the big picture of the area. So that's it. Maybe the last point is to express that, okay, usually you are pushing a lot of technologies coming from the Internet of Things, but in the frame of the Mobility Lab, and especially in my University of Applied Sciences, we are really looking for to reach technologies and to meet them with this user experience approach, just in order to create value. Because if you are just rely on technology, it's not enough today. You really need to provide value to the citizen. Thank you so much for your attention.